So today we're going to talk about real-time communication or RTC. Basically, RTC is um, a protocol for real-time communications. There are two kinds of real-time communications. So one of it is called um, hard real-time, and another one is the soft real-time. And for this purpose, actually, we're going to talk more about the real-time communication in the perspective of WebRTC and use for uh, video conferencings. So that's the specifics we are talking about, and this is more like a high-level concepts of what is this, and then what are actually the high-level architecture being used to make sure that we can have a good video conferencing. So video conferencing is part of the soft real-time system. It is called soft because it's not life-threatening if we got a breakage there, if we got latencies. Uh, so when, for example, if you are doing video conferencing, if somehow you got some lags in between, it is okay in a sense that it's not life threatening. But hard real time system is something like aircraft system where if you get the lags, it's actually going to have bigger consequences. Now that we talk about it, we're going to talk more about the video conferencing part, use terms where real-time communication is to be said. And then real-time communications is basically a protocol, okay? And we're talking about the video conferencing part on it. So in that regards, um, of course, there are several things we need to understood. First is there definitely is the network communications itself, right? The network part of it. And another part is actually the audio, the hardware part, the audio video codec. So it is these two divisions, basically especially the audio video codec, is actually more about the like the hardware stuff, because there are various kind of formats, coding and decoding for audio and video, and different devices, different client application could accommodate different kinds of coding and encoding, decoding, encoding, and decoding. And therefore it is essential to actually know about it. And also it affected like how good is how to achieve real-time communication depending on the coding system and coding system, right? And this will there are several like parts or characteristics that needs to be aware of in terms of the encoding decoding parts. Like one of it is um, the resulting bitrate, because it means like how much it is going to be um, transferred in the network, like how big it is. The smaller it is, the better, because it means we can send the same amount of information within a smaller number of network bandwidth usage. So smaller, better. Another part that it is being trading off with is we have the latency, and basically how much does the encoding going to consume the CPU or the GPU usage of the client devices. So it could be like the CPU GPU uh, costs, because it could be that we make a very attractive low bitrate, but once it got into the client device, it has to be reconstructed with a much higher cost. So it will draw it could, what you call that, eats up the battery usage of mobile quite a lot, for example. So those are like the considerations, the trade-off need to be made, and that's why audio video codec is an important part. There are, of course, there are like several encoding like the H.264, but this one is what you call that, you need it's not open, so it's not like just freely used. If I'm not wrong, this is have royalty cost to it. The one that is free one, like AV1, something like that. So this is an example of video encoding, decoding. For audio part, usually it's a lot more available there, a lot more less complex than the video. So usually the video is the hard part in a real-time communication of a video conferencing. So this is like the aspect need to be considered when choosing coding and encoding and decoding. And for network, yeah, we talk about the bitrate just now. So those are what the RTC is in the high-level components about. Now the question is video streaming like Netflix or Prime Video, for example, is RTC? No, they are not. So that's one of the the things that also comes into my mind when I first start learning about video conferencing. So they are different in a sense that real-time communications uh, require what the name itself says, which is real-time. And real-time at the moment is defined by ITU. ITU, if I'm not wrong, is International Telecommunication Union. So this is the organization. They basically has a target of definitions that something video conferencing communications is actually considered real time when the latency is under 400 milliseconds with a target of 150 milliseconds. And most of the WebRTC is basically a project that trying to make RTC more available in the web systems. Um, Most of the WebRTC applications is targeting 100 milliseconds. This is to simulate a real face-to-face through video conferencing. So this is also a good numbers to know. So when you are creating an RTC system, this could be used like your threshold to alarm about. So the thing, now come back to why video streaming is not a real-time communication, because it doesn't it is a pre-prepared video data, right? In other words, as the provider of the streaming, you can pre-process all the encoding and decoding beforehand. And because of that leniency, it has less challenge compared to the real-time system. On real-time system, it means that after you capture the video, there is a limited amount of time to do the spread over of the information in order to keep the experience to be real. This is right. This is the limitations. That's basically this is the constraint basically that you have to face right after you just capture the video. Compare it with the video streaming where the video was already stored before, which means you can pre-process it in multiple kind of encoding system. And that would mean that it's also easier because you don't need to care about the lossiness of it. You can create an encoding system that is that actually capable to do to cater with lost data, because when things goes in the network, of course some of the data can be lost, and the question is, can the decoding system still render something that is useful with the loss of the bits there? So actually there are the third character, what you call that, matrix for that is being trading off with each other, which is the lossiness of it. Basically, how does it able to cater for lost data? So that's the key point why video streaming is actually an easier problem compared to the real-time system. Essence, to summarize that point, in essence, because in real time you have this constraint to keep the feeling, the experience real, felt like face to face. And in order to do that, it means without that constraint, it means in the video streaming you can do a pre-prepared coding and coding that you can optimize for all these three things. Okay, so that's basically the high level idea about the real-time communication and how we relate something that we could say like the sister uh, case, which is the video streaming, and how we differentiate it. Now that comes into that's already explained. We will now talk more about the architecture. Okay, so web RTC, we will talk more about the architecture that is usually being called out in the web RTC project. So there are three kinds of architecture in the real-time communication for video conferencing that is ubiquitously used. And that would be, first is a peer-to-peer. I'm not sure why this is not centered. So one is the peer-to-peer. And then we also have the second one called MCU, or multi-conferencing unit. The other architecture is called SFU, which is selective forwarding unit, SFU. So these are the three architecture known in WebRTC for video conferencing or communications. Even messaging is also part of an RTC. Basically, any kind of communications that is tried to be real time. And it's just that video is a harder problem because there are more it's delivering more complex data. So peer-to-peer is the simplest part, in a sense that what happened is the devices of the client devices, the one that want to communicate, is actually directly connecting with each other. So what happened in the peer-to-peer, whenever, for example, A, B, C are having a group chat, it means that when A want to send message, the message will be forwarded directly from device A to device B and device C. So and so forth. When B want to communicate, it means B have to to send its message directly to the other two devices. This is what happened. So straightforwardly, the good things about peer-to-peer, it means there is no central server needed. There is no central server needed. It means that the privacy also of the communications also good, because the communicators are connected directly. It means, for example, in the most simplest part, they can establish some sort of a similar like SSL encryptions where only the A and B will know about it. And that's the benefits of the peer-to-peer. No central server, privacy is easily guaranteed. The problem with the peer-to-peer obviously is the fact that the device has to broadcast their message themselves. It means that there is a big toll to the device, the client device, especially if there are too many participants inside the chatting or the communication. So, for example, if this is a video conferencing communications of 100 people, it means for each people, they need each device need to send the same data, the same video being captured of themselves to the other 99 device. It will take a big toll to the client device, and that is very expensive, right? And it will, for example, if it is a mobile, it definitely going to consume a lot of computing power. It will deplete the battery easily and quickly. So that's the problem with peer-to-peer. And what that's we can, in other words, we can say is that peer-to-peer is just not scalable because it's just demanding too much for the client device. Now that we do the peer-to-peer, we go next to the MCU. Okay, so MCU, in MCU, basically what happened is the client, when they are talking with each other, they will be get help from a server, a central server. Okay, so there is a server. If we are the communication provider here, it means we have to provide the server. And what happens is for each client device, it will send its message to the server, and the server will forward it to the other one. The things about multi-conferencing unit is how much the level that the server can have, the level of control. What happened here is the server has several roles in MCU. Other than just forwarding the informations, it's actually also do encoding and decoding. So this especially is useful if the server want to control the kind of data, the efficiency of it being sent to each of the clients. So this means that if, for example, we know that C is holding a legacy client application that is easily handleable in the MCU architecture, because we can uh, encode we can get the data, the video data from A, decode it, and then encode it differently for B and C. For example, if C is using a legacy application, we can still uh, doing backward compatibility to that. So these three devices can still communicate with each other. And the other part, the good part about MCU also, the server can do several other more intelligent stuff. For example, doing automatic subtitling, for example, using machine learning, automatic subtitling, and so forth. That is possible. All right, so we can have to do like more intelligent stuff to be added into the communications. And the downside, of course, because the server's doing this encoding decoding, definitely it's almost impossible to maintain privacy here, because the server need to understand about the video, and there is no, I hardly can think there is a way to get out of that, because if you want to do more intelligent stuff, of course you need to get the content. For example, if you want to create auto subtitling, there is almost no way to do that without doing this, unless you want to install that subtitling system in the client device. but that will be pretty hard to maintain, because it means if you have an update, you just cannot update it. It's just harder to update clients compared to updating server that you own. So the good thing about MCU also, compared to the peer-to-peer, at least this is much more scalable, because the client device, whenever it want to send its message, it's just to send it once to the server. The server is the one that do the heavy lifting to broadcast it to the other participants. The downside of this, of course, because the server has so much responsibility other than the privacy part, the server has much more responsibility. It means that the server costs, if we are in the shoes as the providers, it just much more expensive. Okay. Now the third part is the SFU. In SFU, it's the similar with MCU. It has server. The difference is that the server not holding the same levels of responsibilities. So the server is only doing forwarding from A to B to and to C. It doesn't do modifications like trying to encode it differently to the other one. So in terms of scalability, out of the three architecture, this is the most scalable one, because the server is not doing too much. So the same amount of compute unit in the server can serve much more communication traffic. The downside of this, of course, it means it cannot do the flexibility of MCU. It means if you have legacy system, it wouldn't be possible to actually support it, because you don't do the encoding and decoding, right? And it's also impossible to do intelligent stuff at the server level. So that's what SFU is. If you see, there are always trade-off with the pros and cons with all the architecture. So it depends on what is your use case to choose which architecture. It is also sometimes possible, if you want to adapt all of this, you actually accommodating all this architecture, and then you make an intelligent system to actually decide which one to use for which case. For example, if it is a one, if your chat system can do one-to-one and group chat, maybe if it is one-to-one, you switch it into peer-to-peer. If it is group chat, you switch it to SFU, for example, like that. And if it is a special case units that you want to tag the group chat for example, for resiliency, you might want to use an MCU system. So those are the the architecture in RTC system. And another part also to be remembered, that for each of these devices, there will always be an AT involved, network address translation. Because for example, for the peer-to-peer, in order to A to know how to talk with B, right? A and B, our client device is usually inside a private network. And for a private network to send something out and get it back, it means the for example, A, when A is sending something to B, it needs to know the address B, and it needs to know the public address representations of B. But if B is inside a private network, it means we need something called NAT, network address translation, that makes sure that the public address that representing B, when it got back the data, can be retranslated to which private IP of the B. So that's just an additional things to know. Well, if you are interested, try to Google more about that, or you can comment down before if you want me to explain in more depth about NAT, Network Address Translation System. Another thing also, maybe I need to emphasize the reason why privacy is hard in the other two architecture, even for the SFU. It's almost impossible for I think it's impossible for MCU, but technology change. Sometimes someone have a smarter idea in the future. It could be, but at this level, at my current knowledge, what I know is it's pretty hard even for these two things to do privacy, because if you notice, all client have to send it to the server first. It means if you just try to use the normal TLS, it will be terminated. The SSL will be terminated at the server because A don't talk directly to B. A communicate directly with the server. So it means that the TLS SSL connections is between A and the server. So the encryption will be terminated already at the server, and then the server will forward it here. The same with the SFU, it will be terminated at the server, and then the server will forward it again to B. So when it goes to here, it will be TLS communication between the server and B, not between A to B. So one of the idea, another topic if you are interested, is what is called privacy enhancement real-time communication, PERC. So this is like a project or protocol, I forgot. Basically, the idea of the privacy enhancement real-time communication is some sort of doing a double encryption. So the first encryption will be something that will only be known by the participants, while the the second level is the one that is usual between a two entity that directly communicating, like the normal SSL. So those double encryption is needed. I haven't deep enough about PRC, but currently, if I may guess, it will be some sort of an the first layer of encryption, which supposedly to be known between the client, has to be something that is shareable by all the participants. Why? Because if we really care about privacy, and we also want to make sure that the network bandwidth is as small as possible, it should be something shareable with all the participants. Because otherwise, if let's say we try to make something like AB having its own agreement about what kind of encryption, AC have their own agreement, it means A, if it doesn't want the server to know at all about the content, it has to create that two versions, version for B and version for C, and that will be sent to the server. That's almost useless to have a server, right? It's almost like, why don't you just do the peer-to-peer then? That's why the encryption, I believe, is something that should be shareable between all the participants for that specific messaging channel. So that's the current guess I have, because I honestly haven't dive enough about dive deep into the PERC. But if you're interested, that's also the next thing to know. So that's all about it. That's what I want to share about RTC architecture, and also what is RTC in a very high level. Hopefully that clears up a bit about what is real-time communication, how does video conferencing work at the high levels, and how does it difference with the video streaming like Netflix, for example, like what Netflix, Prime Video, Hulu, Disney Plus are to providing. So that's it. Hopefully that is a useful thing and that is fun to hear about. Thank you for listening in.